Fat Math, the right path to develop the fat brain that you've got. Hello everyone and welcome to Fat Math TV. In this video, you will learn how to define a sequence and identify the nth term given the formula, and to identify or to give the formula for the nth term of the sequence given the first few terms.
Introduction to sequences. What is a sequence? A sequence is a function whose domain is the finite set 1, 2, 3, and so on up to n, or the infinite set 1, 2, 3, and so on. Example, we have here n, which is the domain of the function 1, 2, 3, 4, 5, and this is the range 2, 5, 8, 11, and 14. So these are the a of n. So a of 1 is 2, a of 5 is a of 2 is 5, a of 3 is 8, a of 4 is 11, a of 5 is 14. So if we have that, then we can simply write it as 2, 5, 8, 11, and 14. So the n here, or the domains, like the position of the terms. So we have 2, 5, 8, 11, and 14. So for a simpler notation, instead of writing a of 1 or a parenthesis 1, then we can just say write a sub 1 for a simpler notation. A sub 1, a sub 2 for a of 2, a sub 3 for a of 3, and a sub 4, a sub 5, and so on. So here in this case, as what you can see, the first term can be, or the nth term of a sequence can be written or derived by this formula 3n minus 1. We can have this 3n minus 1 as the generator of the terms of the sequence. So if you will replace n here with 1, so that's 3 times 1 minus 1, that's 2 for the first term. When n is equal to 2, so that's 3 times 2 minus 1, that's 5. If n is 3, that is 3 times 3 minus 1, that's 8, and so on for n equals 4 and for n equals 5. So give the first 5 terms of the sequence with nth term given by a sub n equals n plus 1. So we are asked here to give the first 5 terms. So what we're going to do is, for the first term, just replace n with 1. For the second term, n equals 2. For the third term, n equals 3. For the fourth term, n equals 4. And for the fifth term, n equals 5. For example, a sub 1 is just 1 plus 1. Replace n with 1. So that's 2. And then for a sub 2, just replace this n with 2. So that is 2 plus 1. That is equal to 3, and so on. So the fifth term is 5 plus 1, which is 6. So the first 5 terms of the sequence with nth term given by a sub n equals n plus 1 are 2, 3, 4, 5, and 6. So these are the first 5 terms. Let us have another example. Number 2. Give the first 5 terms of the sequence with nth term given by a sub n equals 5n minus 6. So what we're going to do is just replace n with 1, 2, 3, 4, and 5. For the first term, n equals 1, so 5 times 1 minus 6. So 5 times 1 is 5 minus 6. That's negative 1. So that is the first term, negative 1. For the second term, replace n with 2. So 5 times 2 minus 6. That's 10 minus 6, which is 4. So 4 is the second term. For the third term, 5 times 3 minus 6. That's 15 minus 6, 9. 9 is the third term. Fourth term, 5 times 4 minus 6, so that's 14. And fifth term, 5 times 5 minus 6, that's 25 minus 6, that's 19. So the first 5 terms of the sequence given by, or with nth term given by 5n minus 6, are negative 1, 4, 9, 14, and 19. So very easy. This is just evaluation. We just evaluate 5n minus 6 for values of n equal to 1, 2, 3, 4, and 5. Example number 3. Give the first 5 terms of the sequence with nth term given by a sub n equals 1 minus 4n. Same, you will replace n with 1, 2, 3, 4, 5. So 1 minus 4 is negative 3, 1 minus 8 is negative 7, 1 minus 12 is negative 11, 1 minus 16 is negative 15, and 1 minus 20 is negative 19. So the first 5 terms are negative 3, negative 7, negative 11, negative 15, and negative 19. Example number 4, give the first 5 terms of the sequence with nth term given by a sub n equals 2 raised to n. So 2 raised to n, just replace n with 1, 2, 3, 4, 5. So 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, and 2 raised to 5 is 32. So the first 5 terms are 2, 4, 8, 16, and 32. Example number 5. Give the first 5 terms of the sequence with nth term given by a sub n equals negative 5 raised to n. First term, n equals 1, so negative 5. Second term, positive 25. Third term, negative 125. Fourth term, that is 625. And fifth term, multiply 5, negative 5, so that's negative 3,125. So the first 5 terms are negative 5, 25, negative 125, 625, and negative 3,125. Example number 6. Give the first 5 terms of the sequence with nth term given by a sub n equals 1 over n plus 1. So when n is 1, we have 1 half. When n is 2, we have 1/3. When n is 3, 1/4. When n is 4, 1/5. And when n is 5, 1/6. So the first 5 terms are 1 half, 1/3, 1/4, 1/5, and 1/6. Number 7, give the first 5 terms of the sequence with nth term given by a sub n equals negative 1 raised to n over 2n. When n is 1, negative 1 raised to 1 over 2 times 1. Negative 1 raised to 1 is negative 1 over 2, so negative 1 half. When n is 2, negative 1 raised to 2 over 2 times 2. So negative 1 squared is positive 1. That is negative 1 times negative 1. And then on the denominator, 2 times 2 is 4. For the third term, negative 1 raised to 3, that's negative 1 over 6. Fourth term, that's positive 1/8, and fifth term, negative 1/10. So the first 5 terms are negative 1 half, 1/4, negative 1/6, 1/8, negative 1/10. So as what you can see, this term here, this expression, negative 1 raised to n, makes the sign of the terms change, or they become alternate. Negative, positive, negative, positive, negative. Example number 8. What is the 10th term of the sequence given by a sub n equals n squared minus 20? So the question here is, or what is asked is, the 10th term. So just replace n with 10. So a sub 10 is 10 squared minus 20. 10 squared is 100 minus 20, that's 80. So the 10th term is 80. Okay, for your practice, you can answer the following items. Number 1, give the first 5 terms of the sequence with nth term given by a sub n equals 2n minus 9. Just replace n with n equals 1, 2, 3, 4, and 5. Same with number 2 and number 3. For number 4, give the 5th and the 20th terms just n equals 5 and n equals 20. Replace it with on the 3n plus 10. For number 5, give the 4th, 7th, and 10th. So you have 3 terms there, number 5. So n equals 4, n equals 7, and n equals 10. So you can have here 5 points for number 1, 5 points for number 2, number 3, 5 points. That's a total of 15. Plus 2 in number 4, 17, plus 3 in number 5, that's 20. So this activity can be for 20 points. Okay, let us check your answer. If you're not yet done answering, of course you're not yet done, pause the video. And if you're ready, just click play. So don't forget to like and subscribe Fat Math TV and support by watching the videos. This is not only for the channel, but most especially it's for you because this channel aims to help you in your mathematics subjects. Number 1, the answers, -7, -5, -3, -1, and 1. So these are the first 5 terms. Number 2, 3, 9, 27, 81, 243. Check each term. That's 1 point each term. Number 3, we have 2, -1, 0, 1, -2. Number 4, the 5th term is 25 and the 20th term is 70. Number 5, the 4th term is 2/3, the 7th term is 7/9, and the 10th term is 10/12, or that simplifies to 5/6. What if you're given with the terms or the first few terms of the sequence and you're asked to identify or to formulate the nth term? So what are you going to do? Of course, you will need to think of the answer. So you have to look at the pattern and make n progress from 1 to 2, 3, 4, and 5. In number 1, as what you can see there, it's just like 2 times 1, 2 times 2, 2 times 3, and so on. So a sub n is 2n. Because here, if you can see, it increases by 2 from the first term to the second, from the second to the third, so it's times 2 for the n. And then for number 2, this is -1, 3, 7, 11, 13, increasing by 4. So there must be a 4n there. But then the first term, if n is equal to 1, then 4n is just 4. It has to be -1. So you have to subtract 5 so that your first term will be -1. Number 3, 19, 12, 5, -2, -9. As what you can see, the numbers decrease by 7 as you move from left to right. So if you decrease by 7, there must be a -7n there. But the first term is 19. If it's -7, then it's going to be just -7n. But it's 19. What are you going to do to -7? Because -7n will give you -7 if n is 1. So what will you do to get a 19? You have to add 26. So plus 26. So that the -7 will be positive 19. So if you will replace n equals 2, that's going to be -14 plus 26, that's 12. If n is 3, this is going to be -21 plus 26, so that's 5, and so on. How about number 4? 4, -8, 12, -16, 20. It's just like times 4. So it has to be 4n. 4n, but then the sign changes. So what you're going to do is you have to multiply a power of -1. So there must be a 4n. And then so that the powers will alternate and the first term is positive, you must have a multiple that is negative 1 raised to n plus 1. Because this term negative 1 raised to n plus 1 will make the signs positive, negative, positive, negative. But the first term is positive. So it has to be, if n is 1, it has to be even exponent so that this whole thing will be positive. Next, number 5, 25, 125, 625. So what you can see, it's like times 5 times 5 times 5. So that has to be 5 raised to n. So if n is 1, that's 5 raised to 1, 5. N is 2, 25, and so on. For number 6, 1, 3, 9, 27, 81. So that's times 3 times 3. So it has to be 3 raised to n. But if n is 1, 3 raised to n is going to be 3. But in this case, the first term is 1. So you have to subtract 1 from the exponent. So that when n is 1, this is going to be 1 minus 1, 0. 3 raised to 0 is 1. Correct. And then when n is 2, 2 minus 1 is 1. 3 raised to 1 is 3. When n is 3, 3 minus 1 is 2. 3 squared is 9, and so on. How about number 7? As what you can see here, the numbers on the denominator increase by 1. So it has to be a sub n equals 1 over supposedly n. But n, because they increase by 1. But if it's just n, this is going to be 1 over 1. But it's not 1 over 1, but 1 over 3. So we need to add 2 so that the first term is going to be 1/3. So it's going to be a sub n equals 1 over n plus 2. Number 8, 2, 5, 10, 17, 26. 2, 5, 10, 17, 26. What do you think is the pattern here? There's a plus 3, plus 5, plus 7, plus 9. So it's like it has a different pattern. So you have to think of the answer. But if the pattern is like that, usually it's like a quadratic. So if n is squared, we're going to have 1. But then, first term is not just 1 but 2, so we need to add 1. And then for the second term, if n is 2, 2 squared is 4, plus 1, that's 5. And then for the third term, we have 3 squared, 9 plus 1, that's 10. Fourth term, 4 squared plus 1, 17. And for the fifth term, we have 5 squared, 25 plus 1, that's 26. So in this case, in number 8, you need to think of how to get this answer. Okay, so for your practice, answer the following items. What is the nth term for each sequence below? Number 1, negative 2, 4, negative 6, 8, negative 10. Number 2, 3, 11, 19, 27, 35. Number 3, negative 1, negative 11, negative 21, negative 31. Number 4, 5 7s, 5 9s, 5 11s, 5 13ths. And number 5, 6, 12, 24, 48, 96. So pause the video and answer. Don't forget to like and subscribe FatMath TV. Okay, let's answer. Number 1, there has to be a multiple here that is negative 1 raised to n because of the change in the signs. But then, as what you can see, the pattern is just increasing by 2 if you disregard the sign. So it has to be 2n. Number 2, the numbers increase by 8. So there has to be an 8n. But if n is 1, 8n is 8. So we have to subtract 5 so that it's going to be 3. So 8n minus 5. Number 3, we just subtract 10. So it has to be negative 10n. So negative 10n, if n is 1, gives you a negative 10. But the first term is negative 1. So from negative 10 to negative 1, what are you going to add? You're going to add 9. So negative 10n plus 9. Number 4, for the numerator, it doesn't change. But for the denominator, they increase by 2. So there must be a 2n at the bottom. But if n is equal to 1, it's just 2. So it has to be 7. So you need to add 5. So 5 over 2n plus 5. And then for number 5, it's like times 2. So the first term is just 3 times 2. And then 6. And then becomes 12. That's times 2 times 2. Meaning to say we should have a 2 raised to n. 2 raised to n, but if what do you call this? If n is 1, there should be a times 3 because 2 raised to 1 is just 2. But the first term here is 6. So from 2 to 6, there must be a times 3. So 3 times 2 raised to n. So that's it for this video. This is a bit challenging and you have to remember this and you have to master this because later on when you go to your pre-calculus, you will be applying the same skill in finding the general term for series, the summation or the sigma notation for summation. This is the skill that you need to apply.